Imagine, if you will, a universe not made of particles and waves, but of tiny, vibrating strings. Can this be the fundamental nature of reality? Picture a grand cosmic orchestra, where every note is a different vibration of a string. This is the essence of string theory, our potential answer to the universe's biggest mysteries. It suggests that everything, from galaxies teeming with stars to the smallest photon, originates from these minuscule, trembling threads of energy. Each string vibrates at its own unique frequency, and it's these varying frequencies that give rise to the diverse particles and forces in our universe. From the faintest whisper of a string's vibration, barely detectable, to a booming symphony of interacting waves that cancel each other out, forming matter as energy slows down to less than light speed. String theory, then, paints a picture of a cosmos that's more akin to a symphony than a particle accelerator. But what if our universe is not the only one? What if our symphony is just one of many, each playing their own tune? It's an intriguing thought, isn't it? This is where M-theory comes into play, an extraordinary extension of string theory that takes us beyond the boundaries of our known universe. M-theory posits a universe that is not four-dimensional as we perceive it, but rather one with 11 dimensions. It's a bit like walking into a room and suddenly discovering hidden doors and passages you never knew existed. These extra dimensions are believed to be compactified or folded up on themselves, which is why we don't perceive them in our everyday lives. But what's truly fascinating is the idea of a multiverse, a concept that M-theory boldly brings to the table. Imagine countless universes, each playing out its own distinct symphony of strings, existing in parallel to our own. These universes could very well have their own set of physical laws, their own tune, if you will. Now, you might ask, how do these universes interact? Well, that's where brains come in. In M-theory, our universe is thought to exist on a brain, a membrane-like structure within these extra dimensions. It's possible that other universes exist on separate brains, and these brains might interact, vibrate, or even collide with each other. These interactions could shape the behavior of strings in our universe, influencing the very fabric of our reality. Consider for a moment the implications of this theory. The forces we observe, the particles we detect, and the matter we interact with could all be influenced by dimensions and universes we cannot perceive. It's a humbling thought that our universe might not be the be-all and end-all, but merely a single note in a grand cosmic symphony. M-theory takes us a step further, suggesting a multiverse, a collection of universes, each with its own set of physical laws, its own tune. So, what do these theories mean for our understanding of the universe? Let's journey back to the points we've touched on. We started with the idea of the universe as a symphony of strings. A simple pluck or twist of these strings, the tiniest vibrations, give rise to the fundamental particles that construct the universe as we know it. Each string hums with a unique frequency, weaving an intricate cosmic tapestry that resonates with the music of the spheres. Then, we ventured into the realm of M-theory. This suggests that our universe is just one of many, a single slice of bread in a cosmic loaf. It adds another layer of complexity to our understanding, proposing that we exist in a reality of multiple dimensions, some of which are too small for us to perceive. Our three-dimensional universe is but a single note in a grand multidimensional symphony. Now, let's consider the implications of these theories. If our universe is indeed a symphony of strings humming in multiple dimensions, it means that our reality is not just what we see around us. It's far more complex, far more fascinating, and far more beautiful than we could ever have imagined. If the strings vibrate at different frequencies, then the energy they produce can vary from 0 to the maximum limit set by the laws of physics. This implies that entirely different universes could be created depending on the frequencies at which these strings vibrate. Imagine a universe where energy is forced to slow down to less than the speed of light, causing matter to form in entirely new and unexpected ways. The possibilities are as endless as they are fascinating. As we conclude, let's remember that these theories, while still unproven, open up new horizons for our understanding of the cosmos. They introduce us to a universe that's not just a collection of matter, but a symphony of vibrating strings playing in multiple dimensions. In the grand concert of the cosmos, string theory and M-theory suggest that we may be just one note in a multidimensional symphony, but what a beautiful note we are.